Chapter 10. Gravitation. Gravity is one of the most basic forces in the universe. It plays a fundamental role not only in the structure of our solar system but also in the way objects behave on Earth. In this section, we will talk about gravity. On a small scale, we will discuss topics such as weight, free fall, and ballistics. We will learn the physics of phenomena we experience daily and take for granted. 1. Gravitation. Gravitation is the force of attraction between two objects in the universe. Gravitation may be the attraction of objects by the Earth. This force is proportional to the product of masses of the objects and inversely proportional to the square of the distance between them. It is independent of medium. E.g., if a body is dropped from a certain height, it falls downwards due to Earth's gravity. If a body is thrown upwards, it reaches a certain height and then falls downwards, due to the Earth's gravity. Gravitation may be the attraction between objects in outer space, e.g., attraction between the Earth and Moon, attraction between the Sun and planets.
Gravity, a natural force that pulls all objects toward the center of the Earth, keeps the Moon orbiting, it holds stars together, and binds galaxies together for billions of years, prevents planets from losing their atmospheres. Test yourself, ache. When we move from the poles to the equator. Hence, the value of G decreases. Why, though? What is the difference between gravity and gravitation? 2. Universal law of gravitation, inverse square law, all bits of matter attract all. The universal law of gravitation states that every object in the universe attracts every other object with a force which is directly proportional to product of the masses and inversely proportional to the square of the distance between them. The SI unit of G is nm2 kg-2 and its value is 6.673 by 10 to 11 nm2 kg-2. The strength of the gravitational attraction between two objects depends on two factors: how big the objects are, how much mass they have, and how far apart they are. Ache. What is the difference between gravity and gravitation? Though. What does it mean to say that the force of gravity is proportional to the masses of the bodies, and inversely proportional to the distance between them? 13. Free fall. With negligible air resistance, falling objects can be considered freely falling. Objects of different shapes accelerate differently. Stone vs. feather. Test yourself. 1. A coin and a feather are dropped from the roof of a building. Which one will fall to the ground first? 4. To calculate the value of G, acceleration due to gravity, the acceleration due to gravity is denoted by G. The unit of G is same as the unit of acceleration ms-2. From the second law of motion, force is the product of mass and acceleration. F equals ma. For free fall, force is the product of mass and acceleration due to gravity. Where m is the mass of the Earth and d is the distance between the object and the Earth. For objects near or on the surface of the Earth, d is equal to the radius of the Earth r. Test yourself, ache. Calculate the value of G on the surface of Earth. Though. What is the difference between weight and mass? 5. Mass and weight. Mass is a fundamental, universal property. You have the same amount of mass no matter where you are in the universe. Weight is not fundamental, its value depends on circumstances in the universe. Weight is a force. It is the resultant gravitational force exerted on a body with mass m by all the other bodies on the universe. Weight equals Fg equals gm r2 equals mg, where m is the mass of the Earth and r is the radius of the Earth. Test yourself. A. An astronaut has 80 kilograms mass on Earth. A. What is his weight on Earth? B. What will be his mass and weight on Mars where g equals 3.7 meters per second 2.2. When you put an object on a spring balance, do you get the mass of an object or its weight? 6. Weight of the object on Moon. The mass of the Moon is less than the mass of the Earth. So the Moon exerts lesser force on the objects than the Earth. The weight of an object on the Moon is 1/6 of its weight on the Earth. The weight of an object on the Earth is the force with which the Earth attracts the object, and the weight of an object on the Moon is the force with which the Moon attracts the object. Celestial body, mass kilogram, radius m, Earth. The weight of an object on the Earth is the force with which the Earth attracts the object, and the weight of an object on the Moon is the force with which the Moon attracts the object. Celestial body, mass kilogram, radius m, Earth. A. What will be the weight of the body on the Moon whose mass is 12 kilograms? Seven. Thrust or pressure. Thrust is the force acting on an object perpendicular to the surface. Pressure is the force acting on unit area of a surface. The SI unit of thrust is N or Nm2. It is called Pascal per art. Pressure in fluids. Fluids exert pressure in all directions. Pressure exerted on fluids is transmitted equally in all directions. Law. Buoyancy. When an object is immersed in a fluid, it experiences an upward force called buoyant force. This property is called buoyancy or upthrust. Thus, why objects float or sink when placed on the surface of water. Take some water in a beaker. Take a piece of cork and an iron nail of the same mass. Place them on the water. The cork floats and the nail sinks. If the density of an object is less than the density of a liquid, it will float on the liquid, and if the density of an object is more than the density of a liquid, it will sink in the liquid. 11. Archimedes principle. Archimedes principle states that, when a body is partially or fully immersed in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by it. Relative density. The relative density of a substance is the ratio of the density of a substance to the density of water. It is a ratio of similar quantities and has no unit. There's some important questions for the practice. Thank you for watching this video, and also subscribe my YouTube channel, like and share.